Hello everyone and welcome to another video for Trig. Today we're going to be talking about law of cosines, and we're also going to be talking about applications of solving triangles. And then that's going to finish us up for chapter 7. And then we'll be moving on to chapter 8 in the next set of videos. So for right now, law of cosines. 1 and 2, we already talked about law of sines and ambiguous case of law of sines. So now we're going to talk about law of cosines. So I'm going to draw my triangle for example 1. Alright, so ABC, angle A is 42.3 degrees. Across from angle B, which we don't know, is 12.9. And across from C is 15.4. So normally when we're given a triangle, we would attempt to first, we need to see if it fits ambiguous case, law of sines. This one's a side angle side, so we're not looking for ambiguous. And then we also try to see if we can use law of sines. We would need bits of information. Remember, that is A over sine of A equals B over sine of B, which is also equal to C over sine of big C. Well, looking at this particular case, if I wanted to use A, I am missing a little a, which is fine as long as I have all the information for another set. Well, if I look at B, I'm missing angle B. And if I look at set C, I'm missing angle C. So I can't pick two sets because each set is missing at least one piece of information. For law of sines to work, I have to have one complete set and one set that's missing something. So when that happens, it means it doesn't meet law of sines requirements, we move on to what we call the law of cosines. Okay, we don't have enough information. Law of cosines are as follows down here. A squared equal B squared plus C squared, there's your Pythagorean theorem, minus 2BC cosine A. If you notice and look at these formulas, if A is at the beginning, A is also at the end with the cosine, and then we do B squared, C squared, 2BC. Looking at the second one, B squared is at the beginning, B is at the end. Last one, C squared is at the beginning, C is at the end. It's kind of a little neat way to remember kind of the construction of the formula. You've got Pythagorean theorem, and then you've got the two letters, and then the letter you begin with is at the end. To determine which formula to use, which angle you have been given, and use the formula. So we know angle A, so in this case we would be using the first formula. And they've already set it up right here. And you would plug in all this information into your calculator, which I have done. And once you plug all this in, you get that A is 10.5. So that means this little piece is 10.5. After you've done this, you usually only have to use law of cosines once. Use it once, and then you're able to use law of sines afterwards, which are shorter formulas. Now that I have this, I'm not missing A anymore. I now have a complete set of A, which means I can find B or C. In this case, I'm going to go with C because it's the largest angle. So I'm going to go ahead and find it. So we have 10.5 over sine of 42.3 equals 15.4 sine of C. And that means we know that sine of C is going to be equal to 15.4 sine of 42.3 all divided by 10.5. And you know from the last video we just used sine inverse, which I'm going to do now. And I get that the measure of angle C is 80 point, since we're in one decimal, we'll go to one decimal, 80.8 degrees. So that's 80.8 degrees. And then we do 180, subtract those two. And I get that the measure of angle B is 56.9 degrees. And therefore I've solved the triangle. So, just to recap, use law of cosines. When you cannot use law of sines, it will get you a missing piece of information that you will then be able to backtrack and use law of sines to get the other pieces of information. Okay. Scrolling down, example 2. We can also use law of cosines in a little bit different way. What if we're only given side measures? Here's angle A, here's angle B, here's angle C. Across from A, we have 42.9. Across from B, 37.6. And across from C, 62.7. And I'd like to point out what they say right here is find the largest angle first. It's just kind of rule of thumb is to find C, angle C first in this case because it's across from the largest side. So that's what I'm going to go for. And they've already given us the formula we're going to use. To determine angle C, use this formula. So I'm going to go plug in my information. We've got 62.7 squared is equal to 42.9 squared plus 37.6 squared minus 2 times 42.9 multiplied by 37.6 cosine of angle C. Now, I'm not going to go through all the computation. We'll try to make this video a little bit shorter since we have 2 sections to cover. I think you can handle all of this computation. You get down to 677.12 is equal to negative 3,226.08 cosine of angle C. And when you do your division, you get negative 0.2098894014 is cosine of C. Well, that would mean that I've now got to do the cosine inverse. So I'm going to do cosine inverse of this to get the measure of angle C. And when I do that, I get that angle C is 102.12 degrees. So 102.12 degrees. Now that I know at least one angle, I've got a complete set of C, which means I can find angle A or angle B. I'm going to go with angle A since it's the second largest. So 62.7 over sine of 102.12 is 42.9 sine of angle A, which means that sine of angle A is equal to 42.9 sine 102.12 over 62.7. Sine inverse, so measure of angle A I get 41.99 degrees. And 180 subtract 41.99, subtract 102.12, and we get angle B, which is 35.89 degrees. Okay, so these problems can be kind of long. I'm going to scroll down. Yet again, I'm not going to try to work out all of these. There's only 2 here, but I really want to spend some time with the application problems because we're going to be practicing cosines and sines all over. Make sure you pay attention to this. If it's right triangle, use Pythagorean theorem, sine, cosine, tangent. If the triangle is not right triangle, use law of sines if you can. Remember to check for ambiguous cases, which is our side-side angle. If you do not have enough information for law of sines, make sure you use law of cosines. If you have 3 sides, like in the last one, find the largest angle first. If you're given 2 sides and included angle, find the side across from the given angle. Then use law of sines to solve for remaining values. Remember to check for ambiguous cases if we have them. When finished, verify geometric accuracy. We've already talked about. Okay. So here on example 1, this one is given ABC, so that's 3 sides, which means you have to find an angle. I'm going to go ahead and tell you these measure of angle C. I got 97.47. Measure of angle B is 47.64, and measure of angle C 34.89. Okay. And the bottom one, this one is a side-side angle, so it means it's ambiguous. You have to check for ambiguity. And on this particular one, I had a case 1 that is a, let me draw a little bit bigger. We'll do case 1 on the left, case 2 on the right. So case 1 over here. We'll do case 2 over there. So here, with A, B, C, angle A for case 1 is 55.29, angle C 29.83, and angle B 94.88, and side lengths of 8.61, 5.21, and 10.44. That's my case 1, and geometrically it does work out. Case 2, with an A, B, and a C. We had that angle C is still the 29.83, 5.21, 8.61, and in this case, in both cases, I solved for A first. So in this case, angle A is 124.71, which means that angle B is 25.46, and across from angle B is 2.74. Yet again, geometric accuracy works out for this triangle also. Okay. So remember, if you have any questions on this, make sure to send me an email. But moving on to application problems. All right, a couple application problems here. We've got area of triangles. So we've got a few ways you can find the area of a triangle. You have sine formulas, which is 1/2, 2 sides, sine of the angle that is not across from the sides. So in this case, AB is the sides, and we're talking about sine C. Here, BC, and then sine A, and here AC, sine B. Okay, so we're using two sides, and then the angle that is not across from one of those two. There's also Heron's formula. Heron's formula is side, which is half perimeter. So it's semi-perimeter, and then semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, all multiplied together, and then take the square root. Okay, so application problem number 1. We've got an angle. I'm going to draw a picture. Always draw a picture. I don't know how many times I have to stress this, but I always draw me a picture. It just makes sense. When you're doing trig with triangles, solving these triangles like this, or doing any application, it's good to have a picture. 1.9 and then 24.6. Okay, so we have angle C, which means we're going to be using this formula here. And we have little a and little b. So area of a triangle is equal to 1/2. Side A being 21.9. Side B 24.6. Sine of angle 142.7. And when you multiply this out, you get 163.24 kilometers squared. This is for number 1. Number 2. Number 2, we're going to be using Heron's formula. Now, for Heron's formula, we got to find the semi-perimeter, which is adding up the sides we're given. I'm not drawing a picture for this one since we're just using this formula here. This picture needed to be drawn so you can see that it's the two sides and then the angle not opposite from one of those sides. But in this case, we're not really dealing with angles. And when I perform to find the semi-perimeter, I get it at P 55.2. So the area of the triangle is the square root of 55.2 multiplied by, and I'm just going to go ahead and give you the numbers. It's 55.2 subtract side A, which is 25.5. And then semi-perimeter subtract side B, which is 12.9. And semi-perimeter subtract side C, which comes out to be 16.8. So multiply that all together to take the square root of the number 305055.072, which is 552.32 feet squared. Okay. So these problems are not that difficult, very, very simple. Here, points A and B are opposite sides of a lunar crater. Point C is 56 meters from A. The measure of angle BAC, so B to A to C, is 110. Measure of angle A to C to B is 42. What is the width of the crater? Which means they're wanting this information here. Well, I have not enough information really to start a problem, but I can. I can have enough information if I find what angle B is, which I do 180, subtract 110, subtract 42, and I get that to be 28 degrees. So the measure of angle B is 28 degrees, right here. Now that I have this piece of information, I've got angle B and side B, and I have angle C and I need side C, which lets me use law of sines. So 56 over sine 28 is equal to side C, which I don't know, over sine 42. Which means that side C is equal to 56 times sine of 42 over sine of 28. That gives me 79.82 meters, which is approximately, we can round up and say approximately 80 meters. Okay, moving on. Scrolling down here, we have example 2. Find the area of a triangle. Alright, so to find the area of a triangle, we'll go ahead and draw this triangle since I'm dealing with angles here. I've got A, I've got B, I've got C. Angle A is 48.3, angle B is 38.2, and side C is 22.6. Okay, a couple approaches here that we can talk about is we could solve the whole triangle and then use Heron's formula. Not really, I wouldn't really suggest it, but it is possible. Another thing that we can do is we can find out what one of these two sides are, as well as this angle, and then use a sine formula, which is what I'm going to do. First thing, I want to know what angle C is. Angle C comes out to be 93.5 degrees. If you add these two up, subtract from 180. And then I'm going to use law of sines to find little a. So I've got 22.6 over sine of 93.5 is equal to sine little c, and over sine, not little c, little a, over sine of 48.3. Multiply trick. A is equal to 22.6 sine of 48.3 over sine 93.5, which comes out to be 16.91, rounded 16.91 meters. After I know this, I can now use the sine formula. I'm going to use this one. We'll go ahead and list it for you. 1/2 AC. So I know A, little a, I know little c, which means that then I'm going to have to use the sine of angle B. That's the way the formula goes. So I got 1/2 16.91 22.6 sine of angle B, which is 93, sine of angle B, sorry for that, which is going to be 38.2. And when I work that one out, so 0.5 multiplied by 16.91 multiplied by 22.6 multiplied by sine of 38.2, we get 118.17 meters squared. Okay. Example 3. So we got example 3, 4, and then 5, and then we are done. So example 3. We want to find the distance right here, which is really little c. Okay, we know that angle C is 10 degrees. We know that from A to C is 40, and from B to C is 100. but we don't know little c. We do not have enough information to use law of sines because we don't have angle A or angle B, which means we have 3 missing sets, which means this one is a law of cosines, which is going to be c squared equals a squared plus b squared minus 2ab cosine c. So c squared is 40 squared plus 100 squared minus 2 times 40 times 100 times cosine of 10 degrees. Okay, and then once you work this out, c squared is equal to, so we got, just a second, we got 11600 minus 8,000 cosine of 10 degrees. So c squared is equal to 3721.537976. And we take the square root. So c is approximately 61 feet. Which means that from house A to house B is about 61 feet across the lake. Okay. Example 4, we need to know theta. We're not given any other angles, which means law of sines, yet again, it's off the table. This is another law of cosines problem. I'm going to label this as A, this one is B, this one is C. So I need to find angle A, which means I'm going to use this formula. Plugging everything in, this is going to be 8 squared equals 10 squared plus 10 squared minus 2 times 10 times 10 cosine of A. 64 equals, this is 100, this is 100, that's 200. 2 times 10 times 10, so that's another 200 cosine of A. Subtracting 200, I get negative 136 is equal to negative 200 cosine of A. Divide by negative 200. I get cosine of A has to equal 0.68. And we do the cosine inverse. So measure of angle A, 47.16 degrees. All right, and the last problem for today, example 5. This one is a fun one. At least I think so anyway. Okay. Let me actually gonna do this a little differently. Let me scroll up here about like this, and then I'm gonna open that so I can, there. Okay, now we've got plenty of workspace. Starting at point A, ship sails 18.8 kilometers on a bearing of 187 degrees, then turns, sails 47.3 kilometers on a bearing of 317 degrees. Find the distance of the ship from point A. Well, here's what I want to do. Actually, I'm going to try to draw a straight line. See if I can do that. Okay. So here, that's my ship. And I want to say that this is due north, this is due south. And I'm actually going to draw one more straight line, see if I can do that. Well, almost. But it works for what we need. So this is point A. So it says that we leave from point A and we sail 18.8 kilometers at a bearing of 187 degrees. Well, remember that if we're thinking of general coordinate grid, remember that this is 180 right here. So that means I'm really going from right here like this. And then I'm traveling really at 7 degrees. This is 7 degrees. Okay. Well, now that I've traveled 7 degrees, I'm 18.8 kilometers. Traveling at 7 degrees. And then once I get to this destination, I'm going to call this point B. Then all of a sudden, we're changing course. Okay? Changing course, and this is how I'm drawing this one. Now, just so we remember, if these two lines are parallel, a little bit of geometry, that means that if this angle is 7 degrees, this angle is also 7 degrees. Now we do have to understand yet again, we're traveling true north this way, true south this way. This is almost like another coordinate plane. And I'm traveling 317 degrees. Well, 317 degrees is down here. There's 180, 270, 360. So that means I'm traveling now down this way. Well, if this is 317 degrees, what is this angle here? Well, that's 43 degrees. So now my ship is somewhere right here. And we've traveled 47.3 kilometers. So what we want to know is what is that distance that I've just highlighted right there. How far is the ship from its initial point? Well, here's the big question. Do I have enough information for law of sines? I know a side, I know this angle total is 50 degrees, and I know this side. I don't know these two angles at all. So the answer to the question is no. This is another law of cosines problem. Okay, so this would be little b, what I'm trying to find. That's going to be b squared is equal to a squared plus c squared minus 2ac cosine of big B. Remember, little b and big B, beginning and end. So I don't know little b, but I know that little a is 47.3 degrees, or 47.3 kilometers. I don't know why I put a degree symbol. Probably because it's 12:30 at night or in the morning. C I know is 18.8. So fill them in again. 47.3, 18.8. Cosine of 50 degrees. This is very important. This 50 comes from this entire angle, 7 and 43. Okay. So now I'm going to start filling in my numbers. After I multiply these out, I'm going to get 2590.73 minus 1778.4 cosine 50 degrees. So b squared, I'll go ahead and type these in, 2590.73 minus 1778.4 4 cosine 50. I get 1447.596515. Now I'm not going to round until the final answer because I got a square root. And I get 38.05 kilometers. So I am 38.05 kilometers away from my initial starting point. Alright, guys, with that ends Chapter 7. Next video will be starting Chapter 8, which is going to be imaginary numbers in trig form, so rectangular, polar form, which will be a lot of fun. Pretty easy, just some simple formulas. Alright, I'll see you guys in the next video.